Welcome to Chapter 16, Part 1, Mineral Resources. Looking at the picture, you can see a mining area. This is a strip mine, and this is some drainage from the mine. So, kind of makes you wonder, is the product worth the environmental cost? We're using more minerals, more mine substances than ever before. Some things that you probably think you can't live without: copper wiring to conduct electricity. What about lithium batteries? Can we live without our cell phones? Can we live without our computers? Those are questions that we have to ask, and certainly you'll see a little bit of a glimpse of where those things came from, or parts of those things anyway. Minerals are any organic substance found in the Earth's crust. Some of them are vital for your growth, plant growth. Calcium, phosphorus, iron, and zinc being examples of those. Also, minerals used in industry are aluminum, zinc, gold, and silver. Looking at this table, what you're looking at are what we believe globally that we have in each one of these important metals. Iron, aluminum, copper, and you can see aluminum lots. Aluminum is in the ground, it's called bauxite, and so 330 years of aluminum worldwide. We don't have very many. If you look at the U.S., most of the aluminum comes from either Australia or there's aluminum in Russia as well. And because we can recycle aluminum, and honestly, aluminum recycling, you should absolutely recycle your aluminum. The carbon footprint is less, and obviously we're not mining, and any of these things, when we mine them, come with extreme environmental impacts. So, and we can look at copper, zinc, nickel, chromium. These are all things that electronics use, and you can see that just not much of it left. And if you look at the United States, we don't hardly have any of these reserves remaining. How do minerals form? Where'd they come from? Well, there's 4 basic processes. These are the first 2. Magmatic, concentration, formation of the minerals as magma solidifies. And so down here we have a beautiful piece of granite. Many of you might have granite countertops in your home, and this is from lava hardening. On the other side you have gold, and this gold is actually from hydrothermal processes. Hydro, water, thermal, hot, and they form as the hot water dissolves the minerals in the rock, and then it seeps through the cracks, and this settles out basically, and this gives us gold, silver, copper, lead, and zinc. So you can see why maybe these would be more precious and harder to find by many means. The other 2, sedimentation and evaporation. Sedimentation gives us our iron, sulfates, phosphates, and sulfur. So iron is used for lots of machinery. It's hard. It does not bend easily under heat, so we use it to make lots of different machines, and very, very heavy. But because it won't warp, then the machines are better able to take heat from the friction as they're used. Phosphates and sulfur. Phosphates are used for, you know this, fertilizers. Sulfur could be used for mending soil to increase or decrease, pH levels. Evaporation. This is your salt, and we talked about evaporation leaving salt behind. Gypsum rock. Also, gypsum's used in drywall board, so the walls of your room at home. Gypsum's also a good composite to use to hold together things. So you'll see gypsum used in a myriad of products just as a holding compound. Oh, and that's iron on the left and gypsum on the right. Okay, just like with the coal, minerals are not deposited everywhere. So you'll have high concentrations of them in different areas. You're not just going to find them randomly, yes, randomly everywhere, but in high enough concentrations that it makes it worth mining. So a high concentration, this is called ore. Just like you had coal ore, you have gold ore, silver ore, bauxite ore for the aluminum. And basically, just to give you an idea, iron and aluminum or bauxite, very, very abundant, and this happens to be a bauxite mine that you're looking at. But copper, very, very scarce. So expensive to get out of the ground and very, very precious commodity. Okay, we're just looking at the things that we use a lot of. And this is a percent of U.S. and Canadian consumption as part of world consumption. So we use 30% of lead, overall 20-some% of the aluminum, copper, and this is 2006. I would think that aluminum has gone up substantially. Zinc and gold probably have stayed the same, as well as copper. But all of these things can be, like copper can be reused. Sometimes, we've had this housing bubble that has gone on, so there have been a lot of foreclosed properties, and people are actually going and pulling apart the air conditioning units because there's copper piping in the air conditioners and stealing the copper piping that is available there off of these houses that have been abandoned. And honestly, some people have come home and found their air conditioner lines busted up and the copper taken out of them. So it is a valuable resource. Well, looking at implications of minerals, and again, I go back and I told you in class, this all goes back when we learned about the devastation of mining through coal mining. All of this is applicable to any kind of mineral mining and any thing that is a strip mine. So large areas of land are going to be disrupted. Habitat degradation. There's a use of water in order to separate out the ore and to clean it. Then that water, because it's rushed over that rock composite that has not just what we're working with there, but it's got sulfur and it's got lead in it. because these ores that we're trying to get are not exclusively the only thing in that rock. So, and then affecting the water quality, surface and groundwater contamination due to the increased concentration of sulfur, of arsenic, even heavy metals that have been brought up to the surface, and now they're in a very high concentration and get into that water. So these are interesting statistics. I put these on here just so you get an idea of the waste product that has to be dealt with. And if you look at lead and gold, oh my gosh, you get a teeny weeny bit of lead for everything that you dig up. Most of it is waste. So lots of destruction for just a little bit of gold or lead. Aluminum is 81%, so none of these are minimal by any means. Okay, that's the end of part 1, and we will start part 2 here.